Hello viewers, today we are going to do exponential equations, and remember importantly that the x or the variable must be in the index, so it is going to be in the power. Right, we can solve exponential equations by two ways. Either we use the indices and their laws, or we use the logs. Now we have already learned how to use all the indice laws. There are two previous videos, or there's actually one video which is divided into two parts. Now what is really important for you to remember is that you can use only the indice laws if the bases are the same, because the law we applied here is that if x is to the power of a to the power of x equals a to the power of y, then x equals y. So we basically made the indices, we made that a linear equation, and that is the way we solved it. So that's when you have the bases which are the same, then you can use the indices laws. Okay. However, if you use log laws, you can solve all the exponential equations, right? Whether the base is the same or the base is not the same. And then here the law is the following. If m equals n, then we can also say that log m equals log n. So very often we're going to take the log of the left-hand side as well as the right-hand side to solve these equations, which are exponential. So if we look at the first example, 3 to the power of x equals 27. Now, if you recognize 27 as a cubed number, then you would be able to solve this by using the indices laws. So you would write 27 in index format, which is 3 to the power of 3, and therefore we would conclude that x equals 3. Okay, that is what we have done previously. Now I want to show you how to do that in taking the log of each side. So number one, people, we've got 3 to the power of x equals 27. And the first step is to change both sides to logs. So we're saying take the log off. So this side, the left-hand side, will then become log of 3 to the power of x equals the log of 27. So you basically change each side to its logs. Right, now if you look at the left-hand side, you should recognize the power law of logs. So that becomes x log 3 equals log 27. Now remember, people, we want to solve this, okay? They say solve, which means we must find a number value for x. That means we must isolate x. We want it on its own side, meaning you must take over the log 3. And we will still be doing that by the golden rule, which we use in equations, which is the opposite operation. So between x and log 3 is a multiplication, meaning taking it to the other side will become divide by log 3. Okay, and then you have left over x on the left hand side. On the right hand side, you can press that into your calculator, log 27 divide by log 3, which will give you an answer of 3. So if you compare this now to the indices laws, this is much shorter and easier, but it is because we've got the same base. Both bases are 3, that's why we can use the indices laws. But remember also that all exponential equations can be solved by using the logs. Good, the next example is 4 times 5 to the power of x equals 28. Now remember, once again, they tell you to solve, which means you must find a number value for x. So in this case, we can still move the 4. So we can get x on its own on the one side, meaning we will just simply do Goro is o again, which is on this side multiplied, meaning on that side you will divide by 4, which gives you on the left hand side 5 to the power of x, and on the right hand side it will give you 7. Now we basically have this m equals n. So 5 to the power of x equals 7. It is both the whole numbers. That means log m equals the log n, which means we are going to change to the logs. Now we're going to take the log of 5 to the power of x, and we're going to take the log of 7. Again, people, the rule just simply is be fair. What you do on the one side of the equal sign, you must do on the other side of the equal sign. Then you must recognize again this as the power law for logs. Okay, the power law. Apply that, this becomes x log 5 equals log 7. And once again, now it really is easy, people. We want to find a number value for x. So we're going to again apply Goro's o. This is multiplied. So on that side it becomes divide by log 5. So then you have left over x on the left hand side, and on the right hand side, if you place log 7 divide by log 5 into your calculator, it will give you an answer of 1.21. Okay, now this can always be checked. You can actually press 4 times 5 to the power of 1.21 into your calculator, and it should give you an answer of 28. So you are always able to check, okay, when you have solved for x. Then you can always substitute your value into the original equation, okay, and then check whether your left hand side equals the right hand side. Okay, in the last example, we've got 7 to the power of x minus 2 equals 20. Again, people, you should recognize the left hand side as m and the right hand side as n. So as soon as we have m equals n, we can actually change to logs, or as we say, we will take the log off. So we will just simply change that to the log of 7 to the power of x minus 2 equals the log of 20. And once again, you should recognize this as the power law of logs. Okay, the power law of logs, which means it becomes x minus 2 log 7 equals log 20. And once again, people, we want to solve for x, right? Meaning we're going to keep this on the left hand side, and we will move log 7 to the right hand side. Now remember, there's a multiplication sign in between there, which means log 7 becomes divided on the other side. So x minus 2 equals log 20 divided by log 7. Okay, and you can place this into your calculator. Let me just quickly show you. Log of 20, close the bracket, I like to close the bracket, divide by the log of 7, close the bracket, equals 1.539. 3950. You should now write out all of your digits, or as many digits as possible. So x minus 2 is equal to that. And now, people, we still want to find what is x, meaning we will move over the negative 2 or minus 2, which will become plus 2 on that side. So we're just simply going to add 2. So x becomes 3.53950, etc. It goes on. And then remember, your answers must also always be 3 significant figures. So that's 1, 2, 3, meaning we must round that one. This becomes 3.54. Okay, so what have we done with all of these examples? In all of these examples, we isolate x, okay, which will be in the index on its own, so that we have m, and then all the other numbers on the right-hand side, so that we have got n, so that we can then apply the law. If m equals n, then we can take the log, so log m equals log n. So that is changed to logs, all right? You then put the log in front and the log in front. Remember, you must be fair, so if you do the log on the left, you must also do the log on the right. And then we check which laws apply. So in this case, again, it's the power log, which becomes the power times the log. And from here on in, people, we're just simply doing the golden rule. Goro is o, okay? To solve for x, you will just take over the numbers so that x is left on its own on the left-hand side until you find an answer value for x. And remember, once again, you can actually put this into your equation on the left-hand side and make sure that this is equal to 20. So left-hand side equals right-hand side, then you know your answer is correct.